Okay. Hey guys, how do you think we're going to get rid of this denominator? We're going to multiply by the conjugate, only because if I plugged in a 5, am I going to get 0 over 0?
Yeah.
Yeah, if I would get 25 minus the 0. Okay, so we're going to get 0 over 0. Because we get 0 over 0, we got to try something more. And so that conjugate on this one would be what? Yes, square root of x plus square root of 5. Square root of x plus square root of 5. The conjugate could be from the top to the bottom. You're going to do whatever one has the square roots in it. He's saying, okay, as I look at the top, I don't really feel like distributing all that. That actually looks miserable. So Biscuit, right? Wouldn't it be miserable to go x squared root x? Bleh. Let's go ahead and just factor that guy. What would this one difference the squares into? Love it. And I'm going to just leave that conjugate just hanging off to the side. Because again, our goal is to cross stuff off, you guys. So if I were to distribute it through, I'm probably not going to be able to cancel anything out. But on the bottom, I do want to distribute through because things are going to cancel nicely. Conjugates are beautiful. What's a root x times a root x? X. What we love about the conjugate, you guys, this one's not beautiful. But because they're both under the root, wouldn't that give me root 5x?
Yeah.
Okay, so I'm going to write it just because it might help us. Root 5x. And then here's the beautiful part. What's this going to get me?
5x.
Minus root 5x. Exactly. Minus root 5x. So in a conjugate, these two middle terms will always cancel out. You don't have to write them if you don't feel like you need it. They will always cancel out. And then what will that last term get me? Yeah, a negative times a positive would get me a negative root 5 times root 5. Love it. So we got minus 5. I think that's what you said, Ritzy. Okay. So do you agree the bottom, what is the bottom? It's just x minus 5. Hey, Biscuit, thanks to you when you said, wait, don't I have a difference of squares? Don't I have an x minus 5 on the top? I'm going to write this step out just because this is the first time we're seeing it. If you want to just cancel them out, you can in that previous step. I just want it to look a little prettier before I do that. But if you don't value pretty, I'm not judging you. It just helps me understand it when I'm a student sometimes. But you can just go like that. Those cancel out. And what's left then? Yeah, x plus 5 times a root x plus 5.
Which would equal 10 times.
So then he says, oh, thank you, buddy. Since I've canceled stuff out, I'm going to plug that back in. And when I plug in a 5 there, I'd get 5 plus 5 is 10 times root 5 plus root 5. Could I end there? Could I have ended here? Oops, root 5 plus root 5.
Yeah.
What's my problem? What did I forget?
Square root.
No, without this, it'd be wrong, right? Because isn't it 10 times that? And if I did it this way, Coop, it would have only been that 5 distributed, right? Yeah, so just be careful. I could have ended here if I remembered parentheses. Just curious, though, if this was multiple choice, what is 1 root 5 plus 1 root 5 going to get me? 1 root 5 plus 1 root 5, what is 1x plus 1x? 2x. So what's 1 root 5 plus 1 root 5? 2 root 5s. You got it, guys. So that'd be 10 times 2 root 5.
Which would be 20?
Which would be 20 root 5. If that was multiple choice, this would be their answer. If this was free response, guys, I would end right here or right here. But those parentheses are killer on this one. Don't forget those. On this one, oh yeah, we got to practice some pi over 2. Where's pi over 2 on that unit circle?
Pi over 2.
Lotley's eyeballs just fell out.
So.
Pi over 2, if you see this cute little unit circle, can anyone see that that's pi over 2 up there? Anyone have 20/20?
No.
Okay, well that's pi over 2. Like you said, that's 90 degrees. Boom, that's pi over 2. So you guys, at pi over 2, what's that coordinate?
0, 1.
Yes, thank you, Coop. When I plug in, and I want to remind you guys, this notation of sine squared x is the same as that. These are the same, so just be careful. It's saying find the sine at pi over 2, then square it. They just like to write it this way to avoid parentheses. But just as a reminder, those are equivalent. Ah, yeah? Okay. Let's go plug it in. What's the sign at pi over 2? The signee, the y coordinate is 1, yeah? What's 1 minus 1 squared?
0.
Over, what's the cosine at pi over 2?
0.
0 over 0. But that sine squared plus cosine squared is 1. And so how can we rewrite this numerator? What is 1 minus sine squared? What is 1 minus that thing? You agree with that? Is that coming back? You're like, holy crap. It's been a while since I talked about that. You said 1 minus sine squared is cosine squared. Agreed. I haven't canceled anything out yet, so if I plug in 0, I'm still going to get 0 over 0. Can I cancel anything out now?
Yes, 1 cosine.
Doesn't a cosine cancel out? This squared is going to cancel out with that guy. Psh. I'm going to rewrite it. Biscuit's not, and I'm okay with it. I just like to see, what am I actually plugging in that pi over 2 right there? I'm plugging in just to a cosine. What's the cosine at pi over 2? We've actually done that. What is the cosine at pi over 2?
0.
The x value there is 0. Boom. How about 3? What's the first step that we do? Hey, Lob, when I plug in 3, what would I get on top?
12.
What would I get on the bottom?
6.
Can we be done there?
Yeah.
Totally. Could I end there or simplify it to do? Sure. Those are the best. Have they put that question on the AP test? Sure have. Just plug it in. That's what we always start with. When we get 0 over 0, we have a little shed a tear because we're like, gosh, we got to do more. Okay, last one. The limit as t approaches -2. Did they ask from a certain side? No, so I have to come at it from both sides. So you guys, let's start. Let's start with saying, all right, as t approaches -2, I'm going to start from the left just because I feel like it. And I'm going to say of h of t because that's what they named it right there. Which of these equations should I look at if I'm looking at t -2 from the left side? Left, right? Isn't this first one, my t's are less than -2? So, actually, I'm not going to write h of t right there. I'm actually going to plug in that equation, 3t plus 3. And then we straight up plug it in. What is -2 times 3?
-6.
Perfect, sir. Thank you. Then what happens as I plug in, evaluate that limit from the right? So I'm going to say, all right, the limit as t approaches -2 from the right side. Which function would I look at then? 2 from the positive side would be t values. I'm sorry, I keep saying 2. I mean -2. From the greater side of it. So I would be plugging in into t squared minus t minus 9. Be careful with that negative. We're plugging in a -2 there. What would -2 squared get me? 4 minus -2. 4 minus -2 minus 9. Did the limits equal the same from both sides? Therefore, the limit equals, boom.